I can hear you loud and clear, my friend.
Excellent, thank you very much. So, good morning, everyone. Good middag. Those in the Netherlands, buenos dias. Those in Spain, this is 11 a.m. GMT, and this is adopting HashiCorp Vault. I just want to give you a quick overview about what I'm going to be talking about, and effectively, just taking into the experience of my last 2 years working with certain organizations in terms of large deployments of HashiCorp Vault. The idea was, well, first to actually put up a document which is live, and I'm going to give you I'm going to give access to all of you to that document in terms of what is actually the best practice. What does HashiCorp recommend in terms of how to deploy Vault, and try to make a presentation in this case summarizing some of the points in terms of how you basically take some of those best practices and make it part of your let's say operational runbook in terms of how to make Vault work for your organization. Just a little bit of a quick introduction. The full name is Nicolas Corrarello. You can see a picture of me there, showing a picture of me, showing a picture of me. That is going to be a running joke across a number of the presentations I do over the next year. My current role in HashiCorp is I'm the regional director for solutions engineering. I'm also a Vault open source contributor, and I'm quite proud of that fact. I have been, helping the team with some documentation, also with the, among other things, the Nomad secret engine and some of the improvements with the new console API system. Over the past 2 years, I have worked with a number of companies to operationalize, large deployments of Vault. It's been almost 2 years in HashiCorp. I honestly can't remember when I started using the tools, but I probably started using Terraform and Vault where they weren't that usable. You can find me on GitHub. You can email me, and hopefully, at the end of the talk, I'm going to stay behind to answer everything you have on the QA section or on YouTube, or if you want to email me, that's absolutely fine. Sorry about that. So what are we talking about? We're talking about large-scale Vault deployments. Okay, if you're using Vault as a tool to solve like a point problem, and let me give you an example. If you're using Vault to, I don't know, sign your Ansible SSH keys in your Jenkins pipeline, it's a really cool use case. But some of the best practices here may not apply to you because you're using Vault as a single use case. You're using Vault to sort of mitigate a problem. I honestly think that you should try to look at the whole secrets management picture rather than that individual problem, and that's what I'm going to be talking about, the big picture. But ultimately, if you're using Vault as a tool to solve a single problem, some of these may be overhead to you. In everything I'm going to talk about, there is no wireboarding required. So whether you're using, enterprise or open source, I'm not talking about combining like 5 or 6 tools or doing, sort of a large amount of complex automation in order to make it work. This is how the product was designed to work. Everything I'm talking about is going to be fully supported and up to best practice. I generally start my talk saying, where this is my opinion, this is not my employer's opinion, but this in great part is actually HashiCorp's opinion, and it's the experience we gathered over the last 3 to 5 years. These are no friction approaches. The idea is not to actually, you as a Vault consumer having to go and interact a lot with our team that runs Vault. That's basically not the idea. This is in most cases a pragmatic approach, not a dogmatic approach, and this is a decision that some organizations must take when they reach the right scale. If they can sanely continue to run Vault open source, or if they actually need some of the enterprise capabilities. And of course, this is all properly documented. As I mentioned, there is a full document, and this is all HashiCorp sanctioned. Some people over the past have told us, given us a little bit of heat of our, around our documentation. This is part of the improvements we are making, effectively not just documenting the product and the API and the capabilities and some command examples, but actually giving you some real life examples of how this, this software product is running in a number of places. So let's start by day 0, and this is going to be extremely useful for those of you that don't use Vault to understand what actually Vault does and how it's traditionally architected. Vault is basically a secrets management solution. Now, when it comes to secrets, there are 2 key concepts that I want you to take into the consideration. The first one is, of course, keeping things out of public sight in terms of keeping something confidential. The other aspect, which is also the origin of the word secret, is basically to keep things apart, to introduce that division in terms of who actually need to access this information, how to compartmentalize this information. There are a number of things I always tend to say. Basically, if more than 2 people know a secret, then it's no longer a secret. You are not really being good at keeping it. The other aspect is effectively, how do we give access to that secret? And those are basically, the key improvements in terms of how Vault sees security. Now, I work with a number of large companies, and when you are HashiCorp and you're super innovative, and it's really interesting and really cool to provide these workflows, but ultimately you go into an industry like security, sometimes it's almost an indecency to bring a new product into the security aspect. But on top of that, when we look at secrets management, of course, you have kind of your traditional problems in terms of how do I give access to a secret, and that has been there. How do I give access to, from an operator to a system, and that problem has been there for ages. And I think there is a lot of industry background in terms of that. I think the new problem that has been introduced, when with the proliferation of cloud platforms and traditional multi-tenanted platforms like Kubernetes and so on, is effectively that we can't trust the human anymore as the single source of truth on who gets what. Humans just don't scale that way. When you're deploying hundreds of containers, you can't just have a human checking each one of that containers to see if it can be trusted. So we need to introduce a zero-touch approach to a large number of things. And the main architectural decision around Vault was making it an API-first product. If you have actually looked at the Vault source code, you will see that there is no other way to expose functionality outside Vault if it's not through the HTTP API. And even the CLI and the web UI in Vault, they only talk through the API. So this is truly 100% an API-first product. The next problem that Vault had to address is basically, how do I cannot trust you with a secret if I don't know who you are. So if you're a human, we pretty much have a good industry background in terms of finding out who you are. Okay, you're going to log in with your AD credentials or LDAP credentials. You're going to use like single sign-on system, something like Okta, or you're going to use some sort of OIDC workflow. You're going to use some sort of multi-factor authentication in terms of adding an extra layer of security. That has been sorted. Okay, we've worked 20 years in terms of securing human identities. But if you're a machine, it's kind of a little bit more complicated, because traditionally what we have done is, and I used to work at a hosting provider. Let's look at the common use case. When you provision a virtual machine, that machine jumps between departments, and as it went through a process, we trust it. But most of those processes now are automated. So we need to go back to what do we trust in terms of telling us if that machine is actually trusted. And we went back to the platform. So one of the key innovations involved is that basically you can go and use the thing that you trust, being AWS IAM or Azure Application Groups or GCP IAM, in terms of telling you who this machine is. Or you can use the Kubernetes API to find out the namespace and the service account, or you can use pre-existing TLS certificates, you can use web tokens, there are a number of them. The second aspect is, now I know who you are, I need to define what kind of secrets you can get based on your attributes. And that's kind of where the policy and governance system involved fits in. Based on your attributes, I'm going to just give you access to certain secrets, or give you access to certain secrets under a specific set of conditions, like if you're doing it from the right side of the perimeter, or if, like, I don't know, 3 other operators actually approved you to get that secret. Of course, there is security without audit, and interestingly enough, in Vault, if you have an audit backend set up and that audit backend is not receiving audit messages, Vault will stop giving you secrets, because you need to keep an audit trail of everything that comes out of Vault. And of course, being a product called Vault, it needs to store things. So static secrets, kind of the obvious. You have your third-party API key and whatever. You can store it in Vault. You can version it. But one of the key innovations in Vault is effectively not going to go back to, for example, the DBA or the crypto department to actually generate a secret. What we're going to do is just have Vault, take a specific SQL role or, take whatever, and basically go to your MySQL, to your Postgres, and generate a set of credentials that are right for you. And as we make them very easy to consume, because we do it through the API, we can also make them very, very short-lived. So we take out kind of that credential rotation problem and just, what we're going to do is broker access to a system. We're going to give you access to something. On the other hand, is kind of the encryption services where effectively, you can provision a key in Vault and just consume that key rather than have that key part the security of Vault. And hopefully that gave you a quick overview of how Vault works in 5 minutes or less. Now, this is kind of the interesting part around Vault, and that drives some of both the operational aspect, and it's probably what your security department, if you're working on a large organization, cares about. So everything that Vault stores, it's encrypted using a storage key. Now, of course, we can't persist. We cannot write to disk that storage key because it would be very easy to compromise. So we have to wrap it with something else, and in this case is what we call the master key. Now, of course, we can't persist that master key, and for those who have been using Vault, you might be used to using Shamir, which is what we do to basically protect that master key. We split it 5 ways, and we need a quorum of people to actually unseal the Vault and get it operational. Of course, this is not like extremely conducive with the operational patterns of Vault, and we're going to talk about that in terms of doing immutable deployments and so on. So we introduced functionality where, again, if we don't trust humans in terms of unsealing Vault, we had to go to what do we trust. And some organizations trust, AWS KMS, some organizations trust Azure Key Vault, and we use those to basically secure the master key. You're still going to have something called recovery keys, but I'm going to talk about that one, that a little bit later. Now, in terms of how to deploy the product for a single site, traditionally our model has been it needs to be completely self-resilient. It needs to recover from any kind of failure. And if you've used Vault, we ship HA. And effectively, from a storage perspective, we use Console, which is basically a distributed, in this case, a distributed consensus key value store, where effectively, if you lose a single node or if you architect it properly, if you lose 2 nodes, lights keep blinking. There are a number of reasons why Console is basically the supported storage backend for Vault, but it's mostly about the strong consistency model, the operational features, and to be quite honest with you, it's because when you have a problem with Vault, you probably don't want to call 2 vendors to see if the problem is with Vault or with DynamoDB or MySQL or whatever. So basically, this is the supported architecture in terms of Vault. This is the one we recommend. And if you are not using this one, please don't email me on a Saturday at 7 a.m. It has happened that your Vault service went down. That is effectively what we recommend. There are a number of reasons. You can go through the document and read of them. Now, when it comes to the multi-site deployment model, the architecture we recommend, it requires certain enterprise features, and it's effectively around replication, where you have your Vault enterprise clusters basically talking to each other and distributing those secrets selectively. Okay, this has been proven at scale, and effectively the reason why you cannot just replicate the underlying storage backend is because the underlying storage backend ultimately is looking at binary encrypted data. So you can run multiple separate Vaults. But effectively, when it comes to replicating the data, I guarantee you there are no assurances that data replicated at the storage level will actually be valid when multiple Vault clusters read it. So that's kind of what organizations think on their day 0, right? What is Vault? How does it work? What are the security aspects? And ultimately, how I architect this solution depending on how many AWS regions I'm running, or how many data centers and so on. Now, in day 1, of course, kind of the first thing that we look at is how do we get this running? Okay, we get the big picture. Now let's go into the operational aspects. How do we get it running? And we had a number of recommendations going around, but the ones I want to kind of emphasize on, and this is kind of a combination of some of our previously unwritten best practice and our security hardening guide that it has been also available for a while, is that first, immutable is preferred. We much rather you have torn Vault out and redeploy it, and actually we have a number of patterns in terms of how to do that. The primary reason for this is, of course, compliance. You're always ensuring that your system is just as, defined by your Packer template, or your Packer template again with your Ansible code or your Puppet code or your Chef cookbook or whatever. But most importantly, Vault keeps a number of unencrypted things in memory. And it's not something that you just want to leave the SSH port open and have people poke around and go and drop and replace binaries. Configuration management also helps. We're very strong on that. You will see that traditionally in what we release, it has scripts, and we try to remain agnostic. But there are, there are Chef cookbooks, there are Puppet modules, there are Ansible playbooks in terms of doing this, and some of them, while not supported, they are actually written by people in HashiCorp, and you have a couple of links in the document. SE Linux in this case is not just for disabling. You actually want to keep it enabled. You want to keep it in enforcing. You want to have that mandatory access model where effectively if someone actually gains access to the system, you make them harder for them to compromise anything. Although traditionally, if someone gets access to the Vault system, you should assume that the system has been compromised, and start doing a couple of procedures that we're going to go through. Vault is released quarterly, so ultimately the deployment procedure must be rock solid. You need to keep up fast with this product. Sometimes we ship security fixes, and of course, this is a security product, so you probably want to keep it updated. Console can help with load balancing if you have your 3 Vault nodes effectively. You can apply some of the common service discovery patterns, or you can use just the simple console with some Nginx or HA proxy magic on top to route the traffic to the right node. Or of course you can use elastic load balancing or multiple load balancing cloud offers. You set up telemetry and audit especially, but telemetry, if you're running at scale, it's quite important. It will help you troubleshoot potential issues. Vault, being a security product, uses a lot of CPU, but getting the more information you can, the better. And you need to set up proper backup and restore procedures. Those are run at the storage backend level, and it's generally done through the console snapshot system. Now, if you follow the recommended architecture, I just want to give you kind of the recovery failure scenarios. So, if an individual node fails on either console or Vault, there is no intervention required. The system will keep running. In some cases, and depending on how deployed, if 2 individual node fails, nothing will happen. If the Vault cluster fails, effectively you can reprovision it and use it with the same storage backend. The system will keep operating. Now, it's very important to understand that Vault is not really a web scale operation, application. It's not designed to work that way. It's a security product, and there are a number of considerations. So don't apply the same practices you apply to web scale, to Vault, because potentially you may find yourself into a couple of issues. If you're using console, there is a particular scenario when you lose quorum that effectively console will stop responding. You can recover from a quorum failure in console, but from an operational perspective, the recommended approach is that you basically turn down your cluster and just do a restore from backup. If you're using console enterprise, there are a couple of strategies in terms of how to mitigate that. And then there is a seal key failure scenario, and this one is a very, very important scenario, because if you're using something like KMS to auto-unseal your Vault, and someone accidentally deletes or rotates the key or changes a policy, Vault will actually stop running. And if you lose that key, there is no way to come back from that one. This may sound weird from an operational perspective, but from a security perspective, if someone compromises your seal key, it's pretty much game over. So a Vault is designed to act as it should to protect your secrets. So Vault will not recover for that. The only potential scenario to recover from that is, of course, if you're using open source, have a backup of your seal key, which of course has some security considerations. and if you're using enterprise, you would fail over to your DR cluster or to your performance replica. Now, when you start Vault, there is kind of this first element in the configuration, which is this Vault init command. And the way we picture it in the documentation is basically you follow the steps and you ultimately have a Vault operational. These steps are actually designed to work in a particular way when it comes to an organization. And I think we never presented this in documentation this way, but effectively, what you need to understand is your key officers, that people that get your unseal keys or your recovery keys if you're using automatic unsealing, they're actually sort of the guarantors of the cryptographic trust within Vault. So effectively, it's not like you can just get those keys, chuck them somewhere, and start operating. This is actually an operational procedure. I tend to joke with people that this is the kind of thing where you grab your key officers, you buy pizza, or you throw in robes, and you actually do a stonecutters type ceremony. But effectively, this is a ceremony where effectively, your key officers will send something to encrypt those keys, so they are not public. The operator will actually start a procedure with all of these GPG keys in order to encrypt all the unsealed keys or recovery keys and the root token. Okay, and once everyone has its own keys, they still don't leave the room, because there is one very important thing that exists, the root token. That root token should only be used for the initial configuration. So to set up your initial authentication method, which is traditionally LDAP or AD, and your initial set of policies, and then it should be revoked immediately. Once that token is revoked, people can actually leave the room because the model is safe. Okay, it has been guaranteed that Vault will operate to a secure manner. Now, in most organizations, there are a number of roles that basically have some involvement in Vault. You generally have some sort of operator, okay, which is like kind of the team or individuals that basically do the ongoing deployments of Vault, the updates. In most organizations, generally the team that onboards cloud accounts, in combination with security or your SREs, where the work streams or the different tribes in an organization, they are just consumers. What they want is basically a secret. There is always an InfoSec and crypto department that basically handles the key rotation aspects of Vault, because your storage key, well, it must be rotated. I'm going to talk about that. Your master key must be rotated. Your seal key must be rotated. Your policies must be analyzed. And that's generally where the security team comes in a Vault deployment. And ultimately, you have an audit department that is going to review those anonymized logs that Vault sent out and those metrics to understand if the system is working properly. Now, when it comes to day two, we have Vault up and running. Everything is peachy. We have run our ceremony. We have our key holders. We have our operator. Vault is running. Well, it's time to start actually using it. So it's time to actually start consuming secrets. Now, traditionally, a small organization can generally handle within a single namespace, and that's what we support in open source. But when it comes to large organizations, and the example is I know of one that was running 10 to 15 Vault open source clusters, which were all configured differently, and they said, like, we actually want to use Vault, but ultimately we want to retain a large amount of control of each of our own Vaults, and the solution is basically using namespaces. Where effectively, one part of the organization can have their own namespaces, store their own secrets, maintain their own policies under kind of a centralized umbrella of security. And of course, this is the most frictionless approach, but it might not be ideal for you. Not all organizations are in a maturity level where each individual team is comfortable or even want to manage their own policy. So this is sort of a double-edged sword. So you should consider if you should go with a single namespace approach. You should consider if you go with a multi-namespace approach, or maybe a combination of both, depending on the capabilities that your team requires. The second aspect to set up is that kind of secure introduction aspect, where effectively, depending on your platforms, you're going to set up connections with AWS, with GCP, with Kubernetes, so your workloads can authenticate with a zero-touch approach, okay? Where you actually don't need to have an operator running a script on the machine or whatever in order for that machine to get and maintain a token. you just have that run automatically either via API with curl or using the Vault agent functionality that is included on the binary. And I would strongly suggest you to look into the documentation around that, because we introduced some of the best practices around managing tokens in code inside that Vault agent. And then, of course, the last step is just consuming secrets, okay? And there are a number of approaches to that. You can do that through the API, which is probably the most invasive but most secure aspect. You have your Python, your Ruby, your Java API, it just calls Vault with the token that it already go through secure introduction and just get a secret. But you also have, applications that are, maybe you don't want to recode them, maybe you don't want to touch them, maybe they are proprietary or closed source. And, we have a couple of alternatives to that. You can, do templating. Basically, we have this little binary console template that would render a configuration file template interpolating secrets, or we have another binary that just passes secrets as environment variables. There is another option if you are, heavily using configuration management like in Ansible or, Puppet. You can just use what we call response wrapping to basically within your, within your configuration code, just pass a response wrap secret that gets only decoded in the workload. There is a very good reason for doing this. You basically, if you're using Puppet, you don't want your secrets to end up in the catalogs. And from an audit perspective, you don't want your Puppet master just retrieving secrets. So this, the secret retrieval must be as close as possible to the workload. If you're using Transit, which is our encryption as a service, there are a couple of examples in terms of you generally have like a key officer that maintains your encryption keys. And of course, that role would be delimited to certain administrative operations. So they can manage the key, but they can't use the key. And then, the actual consumers that would potentially, either create a key upon request or decrypt data or rewrap data, depending on what they want to do. So finally, kind of what is the ongoing maintenance of Vault? And of course, updates are there, but there are certain operational aspects that you need to take into account when you're running Vault. The first one, of course, is the storage key rotation. This is a rather simple operation. This is all online. You would issue a Vault operator rotate, and what this would do is just generate a new storage key that gets added to the key ring, and all new secrets will get encrypted with that key. Now, the other aspect is, again, remember that something rotates. When we store the master key, it needs to be encrypted. When we store the storage key, it needs to be encrypted by the master key. So effectively, there is a procedure very similar to the initialization procedure in order to do that master key rotation, where effectively the key officers come back. They introduce their part of the recovery key in order to ensure that this operation is valid, and they're going to go ahead and get a new recovery key out of that process. This is also a ceremony that needs to be carried out. So whereas the storage key is maybe rotated quarterly, the master key is generally rotated yearly, or of course, if there is any doubt of compromise or any weird action, you would call an emergency session where you would rotate these keys. There is a final procedure which is very important, which is the DR promotion, which is valid if you're using Vault Enterprise and you have a secondary Vault replica, where effectively the key officers would need to come back to actually promote a DR secondary to primary in case of failure. Now, I tried to summarize, quite honestly, 60 or 70 pages. No, actually, it's a little bit less. It's about 40 pages of content in 30 minutes, of course, but I would strongly suggest you just go to our website and just download the white paper. It has been done in conjunction with engineering, which is a team that writes Vault, with solutions engineering, which is my team that effectively is working more on the pre-sale side, and of course our enterprise architecture department that are handling these kind of day 1, 2, and end solutions. With customers. And if you need help finding it, you just go to hashicorp.com/resources. And I think you'll have to scroll down maybe a little bit because we released it about 20 days ago. But there you'll find it is Adopting HashiCorp Vault. With that, and perfectly on time, Nick, I'm just going to go ahead and shush. And I'll be